Okay, what section 2.2 is about? It is about conjunctions, and it is about disjunctions. Now, what disjunctions and conjunctions, how they vary, is that conjunctions, if you think of it in terms of English, conjunctions are things that are being put together, and disjunctions that are things that are not together. In math terms, conjunctions tend to be things that have something in common. Like if I had a graph that was going this direction and I had a graph that was going this direction, what a conjunction is what part of the graph do they have in common? Okay, so with conjunctions, we're always looking at what is the overlap or what is true about both of the inequalities. What disjunctions are taking whatever is on both graphs, so if there's two different graphs, and keeping everything. This tends to be an or statement. Conjunctions tend to be an and statement. Okay, so if I were going to say I want all the boys and girls with red hair, I would want to have both of them. Whereas disjunctions, if I say I want all the girls or boys with red hair, I could take any of them. So an and an or kind of separate out your disjunctions and conjunctions. What an or typically means is everything. So if I would have a graph that looked like this, so let's say that I have two different graphs, I would actually have to take everything that is on both of those graphs because this could be true or that could be true. So on conjunctions, we're looking for the overlap. It's called an and statement. A disjunction is an or, where we take everything. So if I would have a graph that two different lines that went like this, an or I would end up having to take both of the graphs because it could be on this or on that. Whereas if I had the same two graphs on an and statement, if I'm looking for the overlap, if I want what is on this one and that one, I would have to just look at the overlap of it, the points that would be on both. So we're going to talk a little bit about conjunctions and disjunctions and how to graph them and how to write them going through these examples. Okay. So conjunctions, it is an and statement. And conjunctions also, we are looking for the overlap. Disjunctions are or statements, and the key word there is we want all. Okay, so I'm going to go through problems 1 and 3 because those are both or statements. And if I were going to go through and graph these two different inequalities, I have x is greater than 2, and if I subtract 5, I have x is less than negative 2. So, on my graph, and I'm not going to put anything really on my graph until I know what goes on there. But if I have x is greater than 2, and I have x is less than negative 2, since it's an or statement, I want to have all points that show up on both of these graphs. So I would have to include both of these graphs on my actual final graph. Okay. And I always draw little mini graphs first because sometimes there's some overlapping and I want to keep my graph, my actual graph, as simple as possible. So this is my graph. On or statements, we still write the set notation, and really it's nothing more than what they have given us. Or I follow the graph. We have x is less than negative 2. We have x is greater than 2. But they would be combined into one statement. So on problem number 3, that's another OR statement. Let's jump down to that. If I go through and solve and I have c is less than negative 3, subtract 7 here, I have negative c is less than negative 6. So if I divide by negative 1, I have c is greater than positive 6. What my graph looks like, I'm going to go by threes, is that if I have c is less than negative 3 and c is greater than positive 6, both of those graphs would come down. And I would write this as c such that c is less than negative 3 or c is greater than 6. So I have my graph and I have my inequality. These two graphs, 1 and 3, are really typical looking OR statements. Typical looking OR statements tend to have graphs that go away from each other with a gap in the middle. Those are really typical looking OR statements. Okay, let's jump back up to problem number 2. What about AND statements? If I go through and subtract x, I have x is less than 2. And here, if I'm subtracting 1, I have 2x is greater than or equal to negative 4. So x is greater than negative 2. Okay. With AND statements, they don't always look like this, but if I put this, I have x is less than 2, and I have x is greater than negative 2. If we see that they're actually going opposite directions, we're looking for the overlap, which is happening here. When I come down and put this on my graph, I just have that piece of the graph where they overlap. This is the only thing that's going to get put on my graph. Okay, I have a solid dot on negative 2, a hollow dot on positive 2, and the line that connects them. That's the only thing that goes on our graph. How AND statements are written, OR statements, we still have the word OR in them. How AND statements are written, as they have a conjunction form, and basically what it says is that you have a negative 2 is less than or equal to x is less than 2. So you have negative 2 and 2 as your endpoints, and then x is the points in the middle, and then your greater than, less than signs match up with your dots. Solid would be an or equal to, hollow would be just a straight up less than. So disjunctions can be written as OR statements. Conjunctions are written as a conjunction form. Questions all there? So on problem number 4, if we take a look at problem number 4, this actually, it doesn't have an and or in OR, but it's a conjunction because it's already put together as a conjunction. And really this middle part goes with both ends. You can, and I'm going to kind of talk a little bit about this more in section 2.4, but this can get split into two different inequalities with that 10 minus 3y that goes with both. It's an and statement. And so if I go through, I'd have a negative 9 is less than negative 3y. So I'd end up with 3 is greater than y, or some people like to flip that around. And on the right hand side, if I go through and subtract, I have a negative 3y is less than 6, so y is greater than negative 2. So, on my graph, what I have is y is less than 3 and y is greater than negative 2. And because I'm looking for the overlap, it would just be this. This is what my graph would look like. And then my conjunction would be y such that negative 2 is less than y is less than 3. Now, 2 and 4, these are very typical conjunctions where you have endpoints with the line in between that says that all of those points inside make this conjunction true. You're not always going to run into 1 and 3 for or statements, 2 and 4 for and statements, and that's where we're going to get down into like 5 and 6, 5 through 8 a little bit. We're going to run into some what ifs that pop up. Okay, so on number 3 or on number 5, this is an or statement. So if we go through and solve, I end up with x is less than 2. Oh, let's change number 5 to an and statement. No. Let's leave it or. Sorry about that. We'll talk about it as an and, but we're going to talk about it both as an and an or. We end up with then as x is greater than 3. We'll talk about, oh, it's got a flip. That's why I'm, sorry about that. Okay, so dividing by negative switches this, and now we have an x is less than 2 and an x is less than 3. This is where the what ifs come from. Oops, sorry about that. I'm running off the page. Okay. If I have x is less than 2 and I have x is less than 3, you have lines that are going both the same direction. As an or statement, we are wanting to include all points that are on both of the graphs. If you're going to include all points on both of the graphs, then the only thing that you are going to put down on your graph is one graph, and it is this line that would go through and take care of both of those graphs. They basically merge together because we want all points together. Okay, so if I want all points on both graphs, I just want all the points. It's just going to be this graph right here. And this is where your statement has to reflect your graph, and your statement would just be x is less than 3. Because you want the simplest statement possible, the simplest graph possible that would basically merge these graphs together. Now, if this was an and statement, then how that changes is we would be looking at all points that overlap. And if we're looking at all points that overlap, it would just be starting at 2, because we would be looking for the overlap. Okay, so there's difference. Or we're wanting the graph that combines all points, and we're looking for just the graph that looks for the overlap. So, as we get to problem numbers 6 and 7, these are also some what-ifs that I want to talk about. So on problem 5, problems 1 through 4 are your typical ones. Problem 5 is what if they're going the same direction. Problem number 6 and 7 is what if we have the same number. What if on problem number 6 we have, and this is why I always do these little mini graphs, what if I have x is greater than 2 and x is less than 2? And it's an or statement. We're looking for all points that show up on both of these graphs. All points that show up on the graph. And so what would that look like is that we don't have a point at 2. It doesn't include 2 because they're both hollow. So our graph looks like this. It almost looks like an all real graph, but it's not because we have a hollow dot right here. So there are two different ways of writing this answer. You could write it as x such that reals except x equal to 2. That's the long way to write it, because you're going to do all reals, but you can't have it equal to 2. Or the shortest way is just to say x doesn't equal 2, which implies that if it doesn't equal 2, it equals all other points. Now the what if comes in. What if this had been a solid dot? What if we actually had a solid dot there on number 2, on the 2? Then this becomes a reals, because if it's an or statement, I have to include every single point, and that point here in the middle is filled in. Then that would be a reals. Okay. So even just knowing if that dot's filled in or not is going to change your answer on that. So what if that was an and in the middle of that? What if we were looking at an and these are two hollow dots? Well, on an and statement, we're looking for overlaps. And is there any overlap on that? Is there any points that are the same? No. So then this is a no solution, because there's no overlap. If those 2 points had been filled in, then the only points that would overlap are the 2, and you would just simply have x is equal to 2. Okay. So and ors are definitely going to shift what your answers are just by even if you have something, a dot filled in or not filled in. So ors, you're wanting to take every point that's on both. Ands, we're looking for just the area that overlaps. And if the overlap is just a point, that's it. Number 8, I'm not going to work through because we're not going to run into that. So I'm not going to work through problem 8. But